Hello everyone, my name is Muhammet Enes Zengin. I'm an industrial engineering student at Bilkent University. Today, I'm going to introduce my final Physics 101 lab projects to you. In this sense, we will be exploring a fundamental force in physics, which is called friction. The goal of this experiment is to determine the static friction coefficient and the kinetic friction coefficient between an object and an inclined surface by using the principle of the inclined plane and Newton's laws to perform these measurements. The basic materials of experiments can be listed as an air table without using its air, for just as an incline, a chronometer, a ruler, an angle calculator app on my phone, and wooden blocks. Here is my setup. This angle is the top view of the airtable. The distance where the object will move is 0.45 meters, as seen in the video. Also, this is the side view of the setup. In the first part of my experiment, my goal was to find a static coefficient. I adjusted angles of incline so sensitive that I can see the critical angles where my object starts moving. When my object starts move with very small velocity, I determined the static friction coefficient by using Newton's second equations. Since the movement was with constant velocity, I assumed that a very small velocity at this point to be constant because I could find the static friction coefficient only this way. As you can see, before the critical angle, such as 11.9 degrees, the object is not moving. However, after finding the critical angle as 12 degrees, we can observe a motion with very small velocity, which will be taken to be constant. While the motion didn't occur in some angles, it did occur in others, and this limiting angle was found to be 12 degrees. Then, by using these formulas, I calculated the static friction and the coefficient as you see. On the other hand, in the second part of my experiment, I calculated the kinetic friction coefficient. After finding the critical angle, I increased the angle of incline so that the object could accelerate towards the bottom of the incline. Then, by measuring the time and distance, I found the acceleration. And again, using Newton's equations, I determined the kinetic coefficient. And I saw that the static coefficient was bigger than the kinetic coefficient. These are some scenes from the second part of my experiment. By measuring the time until the object reaches down, I was able to calculate the acceleration, since I knew the distance. At first, I found the acceleration using this equation. Then, using this, I calculated the kinetic coefficients in different angles. You can see my overall results on this table. Ultimately, I found the average kinetic friction coefficient as 0.2. Also, I proved that the static coefficient is bigger than kinetic coefficient. In conclusion, based on our measurements, we found the static friction coefficient to be around 0.21 and the kinetic friction coefficient to be 0.2, which confirms that static friction is always slightly higher than kinetic friction. Our graphs supported this as well. In the plot 1, the acceleration increased almost linearly with sine theta, and in the plot 2, again, we see the static coefficient is bigger than kinetic coefficient. For the errors, they are mainly caused from angle measurement uncertainty, reaction time while timing the motion, and small imperfections on the surface. Overall, the experiment clearly demonstrated that expected behavior of friction and matched the theoretical predictions. Thank you for listening to me.